of devices that control and protect the operation of AC motors. For example, a controller can start and stop a motor and change its direction, all while protecting the motor from being damaged by excessive levels of current or low levels of voltage. Since your job includes maintaining motor controllers and correcting any problems that arise, you need to be thoroughly familiar with AC motor controllers and how they operate. In this part, we'll look at two common ways used to control the operation of AC motors. They can be controlled manually, and they can be controlled by magnetic controllers. The type of controller selected for a particular motor depends on what the motor is used for and how the motor is designed. Perhaps the simplest way to control a motor is manually. Manual control can be accomplished by using switches. Another common type of manual control switch is toggled instead of pushed to open or close contacts. Moving the switch to the on position closes the controller's contacts. Moving the switch to the off position opens the contacts. When a manual controller is used, an operator must be at the location of the motor controller in order to operate it. An operator must be at the location because the push button or switch of a manual controller directly controls the flow of current from the power supply to the motor. A manual controller is usually located near the motor it operates. This way, an operator can make sure that the equipment is operating properly and can take action to correct any problems that occur. Another common way that an AC motor can be controlled is by using magnetic controllers. Magnetic controllers move contacts by means of electromagnetic switches instead of push buttons or other switches. One type of electromagnetic switch used in magnetic controllers is a contactor. Generally speaking, a contactor is an electromagnetic switch in a controller that directly controls the power to a motor. When the contactor is energized, an electromagnetic field moves an armature that closes sets of contacts to complete a current path from a power source to a motor. One of the advantages of using a contactor is that it can be energized from a remote location using a voltage that is lower than the voltage that is used to energize the motor it controls. This way, the person operating the motor does not have to get close to high voltage when they start and stop high voltage motors. Other electromagnetic switches used in controllers are usually called relays. The construction of contactors and relays is basically the same. In general, though, relays are smaller than contactors and carry less current. In this part, we'll look at a typical magnetic contactor used in AC motor controllers and see how it operates to complete or interrupt the circuit between a power source and a motor. A magnetic contactor is a key part of any magnetic motor controller because it directly controls the power to the motor. Most magnetic contactors have 3 sets of contacts, one for each phase in a 3-phase AC circuit. A contactor may also have additional sets of contacts called auxiliary contacts. Auxiliary contacts are usually attached to the armature and operated by it. These contacts are used to perform auxiliary control functions, such as providing current for indicating lights like the ones used to indicate whether a motor is on or off. An advantage of a magnetic contactor is that it can be energized from a remote location using a voltage that is lower than the motor's operating voltage. This way, personnel are not exposed to high voltage when they start and stop high voltage motors. In this part, we'll look at master switches and pilot devices, which are common types of components found in AC motor controllers. Master switches are manual devices that open or close electrical circuits to control the operation of a motor controller. Master switches control the current flow from the electrical power supply through the operating coil, or M coil, of the controller's magnetic contactor. Additional components commonly found in AC motor controllers are pilot devices. Pilot devices are electromechanical devices that can be used with motor controllers for a variety of functions. For example, a pilot device can be used to sound an alarm or to protect a motor that a controller operates. A pilot device is activated by specific changes in the system in which it's placed. When it's activated, it usually either completes or breaks the circuit from the power supply through the M coil of the controller's contactor. Now, in addition to responding to changes in level, there are pilot devices called pressure switches that operate to open and close a switch in response to changes in pressure. For example, a pressure switch can be used to stop the operation of a compressor when the pressure of a gas in a storage tank has reached a desired level. Another commonly used pilot device is a limit switch. Limit switches are mechanically operated devices that open or close circuits when a mechanical mechanism reaches its limit of travel. This limit switch has a lever arm that's placed so that it protrudes from its casing. When the equipment being monitored reaches its preset limit of travel, it pushes the lever arm. The lever arm, in turn, activates the opening of one set of contacts, stopping the motor, and closing another set of contacts, which results in the motor operating in reverse. Sometimes, a motor's operation is triggered by changes in the flow of a liquid or vapor. In these cases, a pilot device called a flow switch can be used. A flow switch is a mechanical device that opens or closes a circuit in response to changes in flow. Another commonly used type of pilot device is a thermostat. Thermostats are devices that sense changes in temperature. Thermostats can be used to open or close circuits when temperature reaches a preset point. Two common types of thermostats are the bellows type and the bimetallic strip type. In contrast to a bellows thermostat, which may have its sensing bulb located some distance away from the contacts, a typical bimetallic thermostat is located close to the contacts it operates, and it senses temperature at that location. All the examples of pilot devices we've looked at so far have used contacts to make or break a circuit. Another device that can be used instead of contacts to make or break a circuit is a mercury switch. Motors are rated to deliver a certain amount of power. If demand on the motor increases, current flow through the motor increases. If the current is allowed to exceed the rated capacity of the motor, it can cause serious damage to the motor's windings. To prevent such damage from occurring, overload devices are installed in most AC motor controllers to protect the motors from excessive current. Whenever an excessive current condition occurs, an overload device opens the circuit that supplies power to the M coil in the controller's contactor. The de-energized M coil opens contacts in the motor controller, interrupting current flow to the motor, and the motor stops. Both types of overload devices operate on current. Thermal overload devices operate on the heat generated by current, while magnetic devices operate on the magnetic field generated by current. Thermal overload devices use a heating element, which is often referred to as a heater. Current flowing to the motor flows first through a heater, where it generates heat. The greater the current flow, the more heat is produced. When the level of current flow causes enough heat to be produced, the overload device is activated. Now that we've looked at thermal overload devices, let's look at a typical magnetic overload device. You may also hear magnetic overload devices called magnetic overload relays. When the voltage supplied to a motor drops, the motor can maintain power only if current increases. If voltage gets too low, the increased current could seriously damage the motor. In this part, we'll look at different ways that AC motor controllers can protect a motor from problems associated with low voltage. Most magnetic AC motor controllers have low voltage protection built into them. Low voltage protection opens the motor controller's magnetic contactor to stop a motor when voltage becomes lower than the voltage the motor is designed to handle. The last type of low voltage protection we'll look at is a low voltage or LV relay. An LV relay is an electromagnetic switch. It has an operating coil that becomes an electromagnet when current flows through it. When a typical AC motor is first started, current is 3 to 5 times higher than the motor's normal operating current. This surge of current could trip the power supply and in some cases may damage the motor's windings or the cables leading to the motor. In this part, we'll look at a reduced voltage start AC motor controller that can protect a motor against these current surges. Reduced voltage start motor controllers generally use resistors in series with the motors they control. The resistors increase the resistance in the motor circuit, which reduces the level of current during motor startup. After the motor is started, the resistors are bypassed, usually by means of an auxiliary circuit. The most common type of speed control provided by AC motor controllers is step speed control. With step speed control, a motor has determined or set speeds. One example of step speed control is a 2-speed motor that has 2 sets of windings wound in one stator. The 2 sets of windings are controlled like 2 separate motors. In this part, we'll look at how a reversible motor controller can allow a motor to run forward or in reverse.